So water's conveyed similarly all over the world, and it has been for 5,000 years. Basically what happens is water is pumped up a hill at night when energy costs are low, stored in a reservoir, and then distributed through pressurized water pipelines into a city or into a service area. The pumping either comes from, the pressure comes from pumping or it comes from gravity. And embedded in those pipelines are valves, millions of valves that are used to manage pressure so that when you turn the shower on in the morning, it comes out at the right pressure. So we worked with a very large valve company in the United States called Mueller Water Products. And they estimated that if we had the Hydro-XS fully deployed across the United States, we could produce about 12 gigawatts of potential energy. That's enough energy for about 12.6 million homes, 10 San Franciscos, 10 Portlands, that size of a market opportunity, and offset 1.2 billion gigatons of carbon. So that's a significant amount of carbon equal to billions of miles of road travel. So this is what an existing valve looks like. And as I mentioned, there's millions of them distributed throughout water infrastructure. This is the inside of a control valve. They do a great job of managing pressure. They basically use friction, like the brakes in your car, which is set to take out pressure by the water utilities. So what we do is basically take that friction mechanism and use turbines so that we're using a mechanical method for breaking that pressure rather than just burning it off and wasting that potential energy. We've looked at hundreds of these different kinds of valves, and they can produce anywhere from, say, 20 kilowatts of power, enough energy for 10 to 20 homes, up to 350 kilowatts of power, enough electricity for, say, 300 or 400 homes, just from a single valve location from wasted pressure in the conveyance of water. So this is a picture of the Hydro-XS co-located in a water pipeline. And basically the Hydro-XS combines micro-hydro technology, a turbine, with control valve technology, a control system which makes sure that everything is working according to the standards of water utilities and electric utilities for the conveyance of electricity, as well as a grid interconnection panel. And so we work closely to calibrate our system with the existing system in a city, so that when they are at the point where they have to change the pressure within the water pipeline, they can choose between using their existing facility or using the Hydro-XS and producing this new source of energy. It's a very simple, practical approach to solving this problem of generating a new source of renewable energy from existing infrastructure. So in addition to the hardware, we also provide real-time data, which a lot of times water utilities surprisingly don't have, in terms of the flow and the pressure of their system, so that's added value. But we're also showing them the energy savings or the energy generated, as well as carbon reduction. And we're working on quantifying the water savings that also comes from a sort of a smarter way to manage water pipelines. So this is an example of a system that we have in a suburb of Portland called Hillsborough. And so Hillsborough was our first customer, and they said, we really want to do this. And in the first picture over there, you see an existing water pipeline with a valve in the middle there, that blue thing that's sticking up. And then there's a bypass, they call it a bypass, for lower flow. And you can't see it, but there's another valve in that one. And so it's in a chamber about 5 feet wide by maybe 15 feet long. So the Hydro-XS wouldn't fit in there. So we built a chamber right next to it. And here in the middle, you can see the Hydro-XS. In blue, you see the valve, and in yellow, you see the turbine, the generator. And then we pulled a cable about 300 feet underneath this sports complex in the city of Hillsborough, where the grid distribution panel is. And so when the Hydro-XS is running, basically it's generating energy for the EV charging stations, concessions, and lighting at the sports complex. So this particular system is 30 kilowatts. It generates about enough electricity for about 25 homes in Hillsborough, the equivalent of that. It saved the Hillsborough municipality about $1 million over the life of the project. 200,000 kilowatt hours annually of electricity, offsetting about 162,000 pounds of carbon annually. This project costs about $460,000. They got a 3-year rate of return for a project that will last about 30 years. So it's a really economically compelling opportunity for cities who are really interested in climate action. This project's been up and running for over 2 years without any incident. The operators love it. We're talking to them about doing more projects within their city so that they can expand on their sustainability goals. So I'm just going to hit on quickly that there's really compelling incentives now. So water utilities are really strapped for capital. They're always just trying to get by. But fortunately, our technology was written into the Inflation Reduction Act. So there's been no better time for water utilities to improve and build their water infrastructure, especially as it relates to carbon reduction. So water utilities are very mission driven. Their job is to deliver safe, clean drinking water, and that's all they really think about. But the challenge is that they're also big polluters. They use a lot of fossil fuels, and this is an opportunity to reduce that, because we will not be able to solve the challenge of climate change without getting water utilities interested and trying to figure out how to reduce their carbon footprint. There's also incentives from the Department of Energy. There's all kinds of incentives now. There's never been a better time for people who are interested in energy and water. There's capital everywhere now. So this is really the time for cities to modernize and industrial companies to do the same.